In this lesson, we are going to look at Dalton's law of partial pressure. When we look at the word partial, we think of parts. Now, for gas molecules specifically, we don't really look at the part, but we're looking at a mixture of gas molecules of different gases. So in this case, we have letter A, B, C. Those are specific chemicals, okay? Those are specific gas molecules. So I'm going to put this as chemicals. Now, of course, for the total would be the partial pressure of each one of those gases will combine together, give you the total. Another very important formula that you have to remember is this right here. Partial pressure of a specific gas, okay? Specific gas molecules, okay? And that is equal to the total pressure times the molar fraction. When we talk about molar fraction, we are talking about mole. So that specific number of mole for that specific chemicals. Again, we're talking about specific chemicals. That's very important. And that's divided by the total mole. And again, it's all in terms of mole. Now let's do an example problem. A rigid container contains 0.25 moles of sulfur dioxide, 0.5 moles of methane gas, and 0.5 moles of oxygen. The total pressure in the container is 800 torr. What is the partial pressure of sulfur dioxide? The key thing about this is that, again, before we move on, there are different units for pressure, like atmosphere, there's torr, there's Pascal, there's kilopascal. It doesn't matter what is the unit of the pressure, the same logic applies, the same formula applies. So in this case, let's go back and look at this one right here. So first of all, HA, the mole fraction, okay, what do we have? We are looking at SO2. So the mole for SO2 is 0.25. There you go. And then the total is, of course, we add them all together. 0.25, 0.5, 0.5. So what do we have? A total of 1.5. There you go. So now we have a fraction right there, right? So to find whatever we have, in this case, not just A, is X of SO2. So all we have to do is multiply that by the total pressure right there, which in this case is 800 torr. Now we plug into the calculator. You can plug into the calculator 0.25 divided by 1.25 times 800. And after we plug in the calculator, we have 160 torr. And that is the partial pressure for SO2. And you can do the same thing. Of course, in this case, I can ask you the partial pressure for methane. I can ask you the partial pressure for oxygen as well. But the same logic, the same application work as well, okay? Before we move on to the next question, we have to realize this is in mole. But what if it's given to you in different unit? What if it's given you in liters? What if it's given you in grams? You have to convert grams or whatever unit you have to mole. So that's very important, okay? Again, using the same formula. And let's do this problem. Equal masses of He and Ne, which is helium and neon, are placed in a sealed rigid containers, okay? What is the partial pressure of helium if the pressure of the container is 6 atm, which is atmosphere right there? So if we look at this, in this case, this container consists of helium and neon. So that's your total pressure right there. Now let's go back and look at this right here. We're not giving mole, but we're giving mass. But most importantly, we're not giving a specific mass, but we're giving the term equal mass. What does that really mean? That means the mass of helium and neon is the same. So therefore, it doesn't matter what mass you use. You can use any mass as long as they are the same. In this case, I'm going to assume they all have 1 grams of each. So it doesn't matter what it is. So I'm going to assume we have 1 grams of helium and 1 grams of neon. You can use 10 grams, you can use 100 grams. It doesn't matter, okay? First of all, we have to look at this in terms of mole, so we have to convert that to mole. By using the periodic table, we can do that very easily. Here you have the molar mass of helium, and here we have the average atomic mass of helium from the periodic table. Sometimes they have like oxygen gas, so you cannot just use the number here, you have to double it. So be careful with the chemical form. In this case, helium and neon is easy. But what happens when you have O3, O2, N2, or CH4? You have to find the molar mass of that specific chemical formula. In this case, just 4.0 gram. That's easy, right? Helium. And that is equal to 1 moles of He. Look at that. That cancels out. What does that give us? So the math is 1 divided by 4 give us 0.25 mole of He. See how that works? And you do the same thing for neon. So in this case, we have 20.18 grams of neon. Now do you see why we had to know how to convert between mass and mole very quickly and very easy, because it's all embedded in a particular problem like this one, okay? So keep that in mind. So in this case, we have 1 mole of Ne. And we can do the math. Plug in the calculator, 1 divided by 20.18. What do we get? 0.49, okay? So again, if this is multiple choice, you can round it to 0.5 if you want to. So let's assume that this is going to be multiple choice. I'm going to round this to 0.5. How about that? To make your life a lot easier. A lot of time when you have this type of question, there are multiple choice, and on the multiple choice test, you're not allowed to use your calculator. So we have to round it to the nearest possible calculated number we can think of. In this case, 0.49, we can think of this as 0.50, right? So 0.50 mole of Ne. That way we can do the math a lot easier. So if that's the case, what is the total? Well, the total, we just add them all together. So the total is 0.75 mole totals, okay? Now for the question asking for the partial pressure of He, in this case, if we look at this right here, this is going to be our He. So what do we have? He is 0.25, okay? And over the total is 0.75. Well, look at that. This can be simplified to 1/3. With this information, now we can multiply to the total pressure, which is 6. Before we move on, we have to be very careful with our math, especially this is multiple choice. 0.25 and 0.75, what is that equal to? That is equal to 1/3, okay? So if that's the case, we have 1/3 times 6. What's that going to give us? So now our math has been simplified so that we can do it without using a calculator. What is 6 times 1/3? Well, 6 over 3 give us 2. So the answer is 2 ATM. You see how that works? The problem is pretty easy with a calculator, but without a calculator, we get stuck with this, okay? So be careful with that part. Let's try the last question. We have an equal molar of oxygen and nitrogen gas. Whoa, what is equal molar? Well, think of the word equal mole. That is the number of moles of oxygen, and the number of moles of gas is going to be the same. So don't get tricked by this fancy word, okay? So the number of moles of O2 is equal to the number of moles of N2 right there. Or you can just put O and N, doesn't really matter. But the best one is, of course, N2 and O2. We know that because oxygen and nitrogen exist as diatomic molecules. Now the mixture of these two gas at equal molar, which means they have the same number of moles in a container at 296 Kelvin, okay? And the initial partial pressure of nitrogen gas, so again, read this carefully. The partial pressure of nitrogen is what? 0.75 atm or atmosphere right there. And then they have a condition where additional nitrogen gas is added to have double the number of moles. So in this case, we'll double the number of nitrogen gas. Of course, it's going to be in terms of mole. We are going to double, right? Going back to our ideas, let's assume this is oxygen. We have nitrogen. And then to some extent, we're having nitrogen again because we double it, okay? Now we assume it is ideal gases. Determine the final pressure of the mixture after the addition of nitrogen gas. So let's go back to this. We have the partial pressure of nitrogen is what? 0.75. And if that's the case, in terms of equal molar, because they have equal number of mole, therefore they have equal mole fraction, right? That's the term equal molar. So therefore this is 0.75. This is also 0.75 as well. Now if I add in more nitrogen and I double it, well, I'm still going to add in another one. So I'm going to add in 0.75 because I double, right? Because again, the number of moles is double. So all we have to do, we add them all together. 0.75 plus 0.75, that is 1.50 plus another 0.75. Well, that's going to give us 2.25. And there you go. So again, for this type of question, most of the time it is a multiple choice question. So you have to really do your math in your head, or else you are going to struggle with this, okay? So keep that in mind. It is extremely important that you know how to do your basic math and basic calculation. Because on the actual AP test for multiple choice, you are not allowed to use your calculator. So keep that in mind. Try to practice with your mental math skill. And as always, if you have any question about specific content in this video or any question about your practice, take a picture of your work, put it in the forum, and we will help you from there. And we'll see you next time on another exciting chemistry lesson.